quorum here, so I think we'll get started. So again, thank you everyone for joining. So this is, I guess, the first in a while, but Dirac Live demo webinar. And so we're going to be going over a few different things. First, we're going to start with a quick slide deck, go through a few slides. For folks who are, familiar with Dirac or we've spoken to before, I'm sure it'll be a little bit of a, something you've heard before. But trying to give background in terms of who Dirac is, what BuildOS is, and so we'll start there. And really the focus here is, how are we transforming work instructions as well as operator training at scale with automated model-based manufacturing. We are going to, keep Q&A until the end here. So, feel free to throw them into the chat and everything, but we will also open it up so that you can speak and we can answer questions more directly later in the webinar. That'll include, while I'm in the application. So if people have questions regarding functionality, and I can actually demonstrate it, I would be happy to do it that way as well. But yeah, so to get started here. So I think highlighting the problem is a good place to start. So what do today's work instructions look like and why are they the bottleneck? So the three big points here, they're inefficient because of the manual creation, the manual nature of them. A lot of times we're seeing, screenshotting CAD tools, taking photos on the shop floor, taking videos on the shop floor, all of which is super resource intensive, not very scalable, not very dynamic, not very modular, so very manual. Also, the lack of standardization and traceability associated with the current state of work instruction. So again, PowerPoints, Word documents, Excel sheets, PDFs, right? When you create a static document like this, maybe there's a little bit of traceability from like a revision control standpoint, but not a lot of traceability back to the actual original design. And also it's prone to a lack of standardization as well. So within BuildOS, you can actually standardize on a format and things like that. And then the final piece is, because of the manual nature of the work instructions, and also just the lack of work instructions in the first place, there's a huge reliance on tribal knowledge within, we believe at least within the American manufacturing base, as well as the manufacturing base as a whole, right? And so what does that look like? That looks like a lot of experience within the actual, operator or production floor. But that experience is also kind of a crutch in a lot of ways. So folks, relying on years of experience and knowing the process rather than actually following a standardized document. So this is what we believe to be, the kind of issue or the problem statement. And so what was our approach? So our approach and kind of the background on BuildOS is, it's an automated solution and it's very model-based, right? So through the upload of a CAD file, we can automate, we believe up to 80% of the creation of the work instruction. A lot of this is actually simulation driven on the file itself. And then there's obviously a manual piece of it. We were very upfront that, we don't want you to completely, be out of the loop with work instructions creation. We want your engineers creating the work instruction, but we want to be a power tool for them. So that looks like, ensuring that the sequence is accurate, fixing mistakes that our simulation may generate, also inputting kind of that tacit knowledge, so tools and notes, kind of those, rules of thumb that are so prevalent on the shop floor. And so inputting that, but then also trying to capture that and retain that is really big. And then interactive 3D visualizations, right? So this is the model-based nature. This is, by uploading the CAD file, you get a more robust, much more visually appealing and visually detailed work instruction as well versus a photo or a screen capture. And then the final piece, which we think is one of the most important pieces of the puzzle, is a real-time feedback loop. And so we actually have an operator viewer as well, which I can show you kind of a quick, hint at during the demo. But that also allows your operators on the production floor to provide feedback back to the engineers through a really nice dashboard so that your work instructions are not static, right? The work instruction you created 10 years ago is not what your operators are still using today, but rather it's been iterated upon many times to get to that perfect, most efficient work instruction that the operators don't need to ask questions about anymore. So yeah, getting into that a little bit. So Operator Plus, we like to highlight, it is one of the newer pieces of functionality within the application. Again, we're trying to, bring power to the operators and empower them to provide that feedback. We do also have like a basic viewer, which is really great as well. But yeah, the idea is, if you're going to create a digital work instruction, you might as well put that digital work instruction out into the shop floor in a digital format, especially if it's model based. So paperless execution, the feedback we were talking about before, and then also the traceable nature of it. So actually tracking those runs within Operator Plus, so that not only your engineers but also your entire production supervisors or management aspect can track all of this again on the shop floor. Okay, so with that, I think I've kind of hit the high level here. From here, what I'll do is I'm going to jump into a live demo of the actual application. Okay, so I hope you all can kind of see the new screen here. And Gigi, if you could let me know if anything kind of looks funky, that'd be awesome. But so here is the interface of Dirac, well, of BuildOS rather. So I logged into just a demo account. Normally in a real production scenario, you're going to see all of your work instructions demonstrated here within your recent and my projects and things like that. And then from here, I uploaded this centrifugal pump. This is a file that we test on pretty often. It's a great, 90 so part file. I've not done anything to it. As you can see, we still have this modal here to open up the project. And so I'll just jump right in. Okay, so this is going to be a true authentic demo of the application. And so what we see here is the actual interface that an engineer uses to create a work instruction. So right here in the middle, we have our 3D viewer. So I can rotate, I can pan, typical CAD tools or CAD functionality. And then on the left here, we have our entire part tree, right? I think it's about 96 components, so a pretty good size CAD file. We should be able to knock through it pretty quickly. Also here, you'll notice, there are actually subassemblies natively within the CAD file. We adopt those as well. And so, and I guess actually a little bit more background here. So we got the part tree, we've got, our CAD model in the middle, we've got what we call our requirements on the right. So any tools, notes, standard notes, media that we add to the work instruction. We also have a bill of material down here in the bottom left. So that bill of material we're actually generating within the application. So upon upload of the CAD file, we're actually recognizing all the different geometries within the file and recognizing where there are common geometries. So this is actually produced by BuildOS. And then the other interesting thing is this is our model view, right? So this is where an engineer is going to adjust hierarchy and things like that. And then on the right here, we've got what we call our instructions view. So this animation was generated by the application. I did not do that myself. And you'll actually see as we adjust the work instruction itself, we're going to see these update. But you can see that every part or subassembly has a step within it. We're going to condense this quite a bit as we work through it. But this is what we call our instructions panel per se. This is representative of the actual instruction being generated. So I'll talk through this as I go, but I'm gonna actually start working on this file. We haven't really done anything quite yet. So the first thing is I see that this weldment in the bottom, which represents the base, is a bunch of individual components. First thing I'm going to do is I'm going to fix that, and so I can do that by searching on the part name. I can select all of the components in the tree, and then I can create what we call as a combination. We will now treat all of these parts as a singular part. And this is going to simplify the file quite a bit and also allows the manufacturing engineer to really have control over the bill of material, right? We talk a lot about how, within the kind of the workflow of the engineering department, the manufacturing engineer always has kind of a hard time managing their own manufacturing bill of material. And so within BuildOS, we're actually essentially going from an engineering bill of material to a manufacturing bill of material through some of this hierarchy, adjustment. And then interestingly, we're also going to go to a bill of process, right? Because we're going to add sequence to it, which inherently means, there's kind of operations, there's something, there's actual production functionality associated with the CAD file itself. Another thing that I'm doing here is creating clusters. And so this is a way to, again, condense the work instruction, try to jam as much information into, a lower number of steps as possible. This is really key because a lot of times operators don't want to be, managing, the work instruction too much. They really want to focus on building. And so how do you make sure that the work instruction is very dense? And so we do that by creating what we call our clusters. Now, the other interesting thing that we can do is, basically we went through a few groups of fasteners there. We can also kind of reduce this and group these even more. So I'm going to go ahead and I'm going to, grab each of the components of that fastener group and create a kit. And it'll be pretty clear, what that actually means once we see it visually. There we go. And so as you can see, we're already down to 49 steps, and we're going to continue to kind of work through this. And we'll probably, find a few more instances of creating clusters as we go. Actually, I see a few here already. Yep, this group of fasteners. So I can also do this a little bit quicker, and maybe I'll go ahead and do that. I can auto cluster, which is quite nice. So we'll go ahead and do that. And that actually, takes care of quite a bit of it. Okay. That's all. There we go. Okay, so doing a little bit of work up front, and just, I want to know as we're making these changes, these animations are going to update automatically. So you can see kind of as I'm changing the sequence of things, this actually may impact, the animations that get produced. So I think the next thing I'm going to go tackle, and this is kind of going back to that hierarchy question of, are your design engineers actually incorporating manufacturing sequence and operations into your bill of material? So we see this often with files that are overly flat, right? Sometimes we'll get folks asking us, is it good if we have subassemblies built into our CAD files? And the answer is yes. I mean, I think I can speak for the Dirac as a whole. We believe more subassemblies, the better. That means your production's likely going to be more modular. You can build a lot of things in advance. And so you can streamline and parallelize your production processes. And so one thing you'll notice in this file is there are kind of three main sections. There's this motor in the back, which we're probably going to turn into a combination. And then there's this pump over here and kind of a shaft in between. And so actually what I'm going to do off the bat is I'm assuming, we're going to go ahead and purchase this motor. We're not actually assembling this. And so again, can kind of search on that pretty easily and create a combination. Another question we'll get a lot of times, I'm sure someone will ask is, what about our part numbers? Well, interestingly, this is an example file, motor shaft, motor one. We are pulling all of this from the CAD file. So we will actually pull, BuildOS will represent the part numbers and or descriptions from your CAD file right in BuildOS. So you don't have to worry about renaming ideally. And I'll go ahead and rename this to motor. Okay. Now the other thing though, I really do want to group kind of this pump section back here. And so I can just start kind of selecting parts and creating subassemblies. So this is pretty interesting. You can change the hierarchy, create subassemblies, break subassemblies, all within BuildOS. And this is good because you are actually creating your manufacturing bill of material right here in BuildOS. You're unifying essentially, the different bills of material while also managing them actively. And, it really empowers the manufacturing engineer to take control over that manufacturing bill of material. So I'll go ahead and I'll hide that just to make sure I get all this in here. Okay, probably grab these as well. Okay, and I can just drag and drop these right in. Cool. And then I think the other section that I really want to capture is this middle section with, the house bearing per se. So we'll grab this, we'll create another subassembly, call it the housing. I'll actually include the shaft in there as well. Okay. And I think from there we should be pretty good. I remember that I could potentially make some more kits out of these things. Okay. As you can see, I mean, we've kind of simplified this quite a bit. So I'm going to do a little bit of two things now. So I think our hierarchy looks pretty good. I'm sure we'll adjust as we go. Um, but I'm going to do a little bit of manual reordering and then go ahead and actually leverage the automated sequencing that we have. So I'm going to start with the base. I want this to be up top. I'll leave the motor down here. And then the pump is probably the first thing I'm going to go tackle. So if I go in here, I'll start with the base. I'll go to my instructions. Perfect. So that just updated. The first piece within any subassembly will be, I will not have an animation. And I'm just going to set the rest of my steps to this perspective so that we can start moving in. The first thing we're going to do is we're going to jump into this pump assembly. I'm going to go ahead and I'm going to get a suggested order for this. I think I may actually want to break some of this up. I'm going to go ahead and I'm going to accept this though. And then I want to make sure, actually, let's start with the casing. Ooh. Okay. Actually, I need to break up this dissolve this. There we go. Housing coming in. Swearing first. Okay. And so you'll notice that these actual animations are going to update as we go, which is great. We're going to need to break up this set of as well. Packing gland's going to go last. I think I may have gone a little crazy with the clusters there at the start. Let's actually go make sure. Actually, we're going to give this a quick refresh just because my the rotation aspect of it was getting interesting there. Okay. We're going to set this through the rest of it. Very nice. I can actually, at this point, I think on the next one, I'll leverage a new feature that's just coming out now. It's available to some customers at the moment. And it's going to be the section views. Actually, I think this piece here, we're going to need to drag in. There we go. Okay. And so I'm going to go ahead and I'm going to kit the rest of these so that they're all coming in together. And then I can leverage section view. So I can add a plane here. We're going to flip that. So this is a new feature that we just added to the application and we'll be releasing publicly soon. And allows you to see some of these inner kind of components a lot better, especially understanding what this product looks like at a section. We've got a customer now that is making some pretty high-tech lenses, and so this was a really critical feature for them. And so I can go ahead and I can approve that. Perfect. All right, and we're back to that normal view. Okay, so this is, that's a good representation of a subassembly. So building the pump out before we actually go and install it to the rest of the components, or the rest of the assembly rather. So here's the housing with the shaft. So let's kind of walk through this quickly. I think what's key is we're definitely going to start with the shaft. So we'll set that. Might as well just bring this bearing housing to the end here. Okay. I think we're actually going to have to break up this bearing cover because one needs to be installed after the actual housing comes on. So very quickly, we're able to actually manipulate, the hierarchy associated with the subassembly. And again, we'll see these actual animations update as we go. excited to actually see that kind of happen in front of us. Let's see. Yep, there we go. So that's a great representation again of as we change the sequence, and that sequence is correct, those animations will update automatically, which is really key. Because alternatively, right, if you're taking a screenshot or taking photos, a lot of that wouldn't happen. But again, those static images, in this case, are not static. Then bring this in. Great. And then we can go install this whole component. Now, what's interesting is it's at this point through this kind of virtual build that we're doing, that I can see, there's definitely a mounting plate down here, and I may actually want to install that to this housing, prior to installing it, to the rest of the assembly. So I can pretty easily just go over here, again, adjust this hierarchy. I can add these to that subassembly, and then if I jump back over here, now this is being represented. Let's go make sure the order of this kit is correct. So we want to start with, this washer, then the bolt, then that second washer. There we go. And when I jump back over here, now that is being represented. Perfect. And then when I go and install the rest of this, that is now represented as a part of the subassembly. And let's see. So again, maybe we should check on some of these kits, make sure these all make sense. Okay. Bolt. There we go. And I think the other thing actually, so if I jump back over here, right, and this step was to fasten this down. I notice, again, as a manufacturing engineer, I was handed this design, and I noticed there's kind of this portion where I can slide in a bolt and a washer, prior to actually dropping this onto the base. And so when I see that, I'm like, okay, well, interesting. I may want to, again, adjust hierarchy a little bit. And I may want to go grab, just the washer and bolt here and actually drop this into my subassembly here. And what that's going to do is, I actually probably want to bring in the washers first. Rather, I probably want to bring in both of these as a sub almost. And so I can go ahead and I can create, indicate to my operator that really I probably need to, let's see, where's the bottom here? Uh-oh. Here we go. And the next step, adding those washers. This will update obviously, and then go ahead and add these to the subassembly here. Let's make sure that subassembly is represented correctly. And then when I have it like this, I can go ahead and install that onto the base with those bolts in there. So this is one of those, kind of design for manufacturability checks that you can do within the platform because you're doing a virtual build. So ensuring that those bolts get installed into that, motor prior to installing out of the base, and trying to just reduce rework in that sense. Okay. Yep, and then actually make sure I bring these up. This will update, would be my assumption, as we kind of go through, or it's still generating new animations. Okay. We'd work through this, we can add that housing. And, at this point, we are pretty close to, the end here. I'll probably bring up this coupling, obviously. I think there's a group of pins in here. I'll break that up. Make sure this comes before that. Very nice. Bring in the coupling. Probably bring this up before that coupling. There we go. Just very easily, drag and drop editing sequence here. actually looks like I'll probably add this to the motor. So I can go motor here, create a subassembly, make sure I install. There we go. This key before I push it into the actual coupling there. And then final thing. There we go. So, I know it's not perfect, but from a sequence and animation standpoint, you can really see what's happening here. We've got 35 really great steps putting this whole thing together. And then to talk through a few other things. So something else that came out pretty recently is this DFM checker. And so we're looking for two things. We're looking for model overlap, and then we're also looking for what we call path obstruction. And so let me just jump to a quick step of path obstruction. That's not a great example because we're coming in from the side there. And there may be a few examples of that. But the idea is if your animations are all correct, we are actually looking for path obstruction of parts. And then additionally, we are looking for model overlap. So in this case, we're seeing that there's model overlap of these components of the pump casing, the wear ring, and the impeller. And so we can go actually highlight that as well, or remove highlight here, and you can kind of see the different parts. A lot of CAD tools do this, but doing this for the manufacturing side of the house is pretty key as well, along with those path obstructions. You can also toggle this on pretty easily. So if you're looking for these things, you can go take a look. And if not, you can kind of get rid of it. So up to you as a user, really depends on what you're focused on as a manufacturing engineer at the time. So I'll go, clear all the highlights. There's also, some more the classic things that have been a part of the application for a long time. So for example, adding tools, notes, standard notes, and media. So this is our way of allowing a user to add tools to the actual work instruction, as well as notes. So indicating, potentially I want to check the surface. It's called a surface check. And so this will be an indicator to the actual operator saying, hey, make sure you're doing this. And this is also, we're creating libraries of these. You can go ahead and if you notice, so I'd actually made this a global tool, which is indicated here. We're actually associating these things to parts. And so a good example of this is, for this pump packing set, right? I can add potentially, let's add a piece of media. Well, let's add a standard note rather. And let's do that surface check again. And so just as an example, we're going to make this global. This is going to be represented on this one, as well as each other instance of this actual, part. And this will persist over not only this work instruction, but also every other work instruction in which you put the same, component in that assembly. And so we're really trying to both capture the tacit or tribal knowledge of your organization through these nodes, tools, and media, but also then actually apply it across all of your work instructions to ensure you're not just capturing, but you're also leveraging that information in an intelligent way. So that's kind of our requirements table along the side here. Let's see. So as we go through some other functionality, I'll jump over to instructions. We're taking a look here again at our section view, which is awesome. Let's maybe add some annotation to this as well. Ensure alignment. Of this, I think this is what we call the lantern ring. Okay, very nice. And so here's a really clear way to call something out for the operator. Maybe we make this a little bit bigger actually. Select it, there we go. A little bit clearer. Okay. And so you can call this out to the operator. Oftentimes we'll see this when it's a really critical thing. Even sometimes folks will call out like, make sure you're wearing your PPE for this step or check the tools for this step to make that ultra clear for the operator. Okay. And I think just to call out a few more things. So let's say our work instruction is complete now, right? At this point, we want to get it out to the operator floor. There is an actual approval process within the application. So I can go ahead and I can review this or submit it for approval. Now on this seat or account, I am an admin, so I can approve the work instruction myself. Alternatively, you would actually go share it with another teammate, so another engineer, in which you can use the sharing functionality and select from your users. So potentially Austin on the team, right? I'd want to share with him. I can invite him. I could also pass ownership of the project to him. And then from there, he could also go ahead and actually approve the work instruction itself, which is really great. I'll go ahead and approve it myself. And then from here, I could create a new revision, etc. And then the other key to this is that when leveraging our operator viewer, which I'll kind of give you a sneak peek to, and the actual work instruction must be both approved and shared with that operator. So it allows you to kind of control, which stations, which operators are accessing which work instructions. It gives you a little bit more control over that, and also ensures that your operators are only ever consuming work instructions that are approved by the manufacturing department. What's interesting about this as well is that you can have an approved, Rev 1 out on the shop floor, active being used. You can then have a Rev 2 that that's in drafting, that you're working on improving upon based on feedback from your operators. And then as soon as you press approve on that work instruction, it'll instantly be available to the actual operators on the shop floor. So it's a really, really fast way to iterate and approve on those work instructions over time. And so to jump into it, really quick, you can actually preview our what we call our operator mode basic from your engineering seat. It's going to look remarkably similar to what we're looking at now. We blow up the buttons a little bit. We make the requirements a little bit clearer, and we flatten the tree. But if we kind of just jump through a few of these, oh, interesting. It looks like let's see, because of the section view, it actually persisted, which is interesting. But if I jump over here and let's create a new revision. Here we go. Okay. And we jump into operator mode. This is what an operator would be actually seeing step by step. Okay. Very nice. Okay, so at this point, let's actually open it up for questions and answer. So Gigi, I'm not sure how we do that but if we have a few questions maybe in the chat perhaps.
Yeah, feel free to type the questions in the Q&A section if you have them, or raise your hand. We can just have a quick chat. Yeah. All right, we have a question, Trevor. What is the workflow for updating the animated work instruction when a SolidWorks drawing changes?
Yeah, no, that's a great question. So we have, as you saw, I created a new revision of the work instruction here. From an approved work instruction, you can both create an instruction revision, which is a copy of that same CAD file. But obviously you can change the sequence, you can change the notes, things like that. Alternatively, you can also create what we call as a model revision. So a model revision allows you to upload that updated CAD, SolidWorks file or whatever CAD tool you're using. At the moment, you do have to do a little bit of additional work to get that back into the same state. But we do have a great product roadmap slide coming up. So before we end this, we'll look at kind of future what we're building. One of those is what we call smart model revision, and that technology is going to allow you to automatically update your work instruction with that new CAD file. So we will actually map the existing work instruction to the new CAD file and recreate that whole thing for you. So that will be a big improvement upon that. And we're targeting, the next few months to incorporate that.
All right, our next question is, how do you manually change the animations to have the parts go on correctly, i.e. not pass through solid parts?
Yeah, great question. So I can show that. Let's use this as an example. And so I can go ahead and I can just do edit animations. I can then select what it is that I'm looking to edit. Ooh, there we go. Custom. And then those animations will be updated.
Uh, Andy, it's important to note that we're actually dynamically and automatically updating these animations on the fly. So if Trevor had waited an extra second for the new animations for this step to be generated, the software would have automatically corrected and added new correct animations. It just takes a second. That's what the little spinny blue icon is on the part to the on the left panel.
And
Thanks,
for
Phil.
anybody who doesn't know, that was Phil, our co-founder and CEO. He's on here as well.
Everybody. Yep.
All right. Next question is the operator will have an operator account that walks through them through each step of the assembly without being able to edit any steps. That was a question. And is there an automatic timing requirement for how long the assembly should take?
Yeah, so great two questions. The first of which, yes, so the operators actually do have accounts. So the admin on the team is able to invite the operators via email. And so an email would show up in their inbox, they could create their account, etc. And when they log into that operator account, like I mentioned, they'll see the work instructions that are shared with them and approved. And yes, they will not be able to edit the actual sequence or really anything about the work instruction. I will say though that they are able to rotate the model in each step, as well as they can actually access the model view as well. So they can see the completed CAD, CAD file assembly. Um, and for those perspectives though, for each step, that will be set to a default by the engineer. So it'll always revert back to this like very nicely, viewable instruction, but they can't actually edit anything. So it'll walk them through it that way. And then on the second one, is there any automatic timing requirement for how long the assembly should take? So this is an improvement that we're going to bring to Operator Plus soon. So essentially being able to set a standard time for a build. Additionally, within Operator Plus, we are tracking the time that it takes to complete each build. And so soon you'll be able to kind of make a comparison there. What's interesting also is, typically standard times are kind of more the ERP world. We're not, all the way into the ERP world, but we do see a lot of value of being able to control or like input that data within our product, and it allows you to kind of start looking at routings and kind of the logistical procedure associated with the shop floor, and start to parallelize, sub-assemblies, things like that. So that opens up a big door for us in the future.
Great. And the next question is, where does the software reside and where do the instructions reside?
Yeah, great question. So we are a web-based platform. So we are hosted entirely in AWS. We do have multiple options depending on, what type of data you're working with. And what I mean by that is our standard offering is just the AWS Commercial Cloud. We do also have a Dirac hosted AWS Gov Cloud, and we can also deploy onto your AWS infrastructure. So we have a lot of options there from a security standpoint. All of the data does exist in the AWS environment. But we have, very, very stringent security requirements and controls in place. And then I think, what was the second piece of that, Gigi?
Where do the instructions reside?
Oh yeah, so it's all in AWS. And so you're accessing it via a web browser. As you can see here, I'm in Google Chrome. So through the internet to the cloud.
Great. And the next question is, can the operator provide feedback to improve order of operations, potential fixtures and jigs, or checks, etc.?
Yes. Wow, that was a good question. So we have two types of operator accounts. One is this, basic viewer that I was showing you here. So this we actually give away for free. People call us crazy, why are you not charging for that? We are so passionate about the fact that you are making a digital model-based animated work instruction that we want to make it as easy as possible for you to actually deploy that onto your shop floor. And so that is that basic operator view that we're giving away for free. We then also have what we call Operator Plus, which they can also access the work instructions through. And in terms of the feedback, that you had to close the loop on that. So within the basic viewer, there's no feedback functionality. With an Operator Plus, there is feedback functionality, and that comes in a few different ways. There is, just a work note that they want to jot down a note. There are suggested changes. There's reporting of errors, and there's actually data collection as well.
Great. And next question is, let's see. Are the license seats for operator viewing different from the engineering, work instruction, design seats? I think you sort of answered that. Is there anything you want to add, Trevor, before we move on to
Yeah,
the next
no,
question?
absolutely. I think from like a subscription or licensing standpoint, yes, these are separate seats. They're purchased separately. We charge primarily for the actual engineering seat, and then also these operator seats do come separately. Well, at least the Operator Plus, so they are managed differently. The cost structure is different and everything. Yeah.
And there was another question that Phil answered, just type the answer, but so everybody can hear it. Does this record or timestamp when steps are completed? Phil just mentioned yes, that's via Operator Plus. The next question is, will the software detect if pieces need to be installed on an angle, and will it detect collisions when installed on the angle?
Yes, absolutely. So let's actually go look at so this piece here. So having worked with this file a decent amount, you can see that this component is actually being installed. The optimal path we determined was not just along one of the model's like XYZ axes, but actually at a separate angle. And so we are kind of evaluating across a lot of different angles. And yes, we will still do all of that collision detection, regardless of the angle in which the part's being installed.
And then are work instructions compatible on different devices, different screen sizes, i.e. Android or Apple-based?
Yeah, absolutely. So again, because it's a web-based application, it really is easy to deploy to any sort of computer or device. I'm just running on a typical laptop, nothing too crazy, and we've never really seen any issues on that front. And then when you actually go do deploy it to the operator, again, you have a lot of flexibility in that way. And so we have customers who are using anything from like just monitors that are mounted to an assembly station to tablets, whether it be Apple or Android, really doesn't matter. So anything that you can download a web browser to, we recommend Chrome, and you can connect to the internet, you should be able to, access BuildOS. Obviously, a phone is going to be a little hard to see with the actual model and everything in there, but we found that tablets have been a huge hit. Yep.
And does the software work with NX? If so, will it keep NX attributes such as part numbers, etc.?
Yes, that is a great question. So we are good friends with the folks over at Siemens, and so we've actually done a lot of work to accommodate, NX and Team Center and Siemens ecosystem file types. So out of NX, we recommend using JT files. They're actually awesome. They're very lightweight, and they do still house all of that metadata associated with your NX CAD file. And so we can pull all of that in. That does give us opportunities to look at part number, descriptions, also, specific attributes that you have added to your CAD files in NX. So we have an awesome customer who's leveraging that quite a bit. So yeah, yep, we can bring all those attributes in.
And then we have two questions that are quite similar. What is the price of the licenses? And then how much does an engineering seat cost? And is there a team price for a larger number of seats?
Yes, absolutely. So we do bulk pricing for sure. If we want to talk pricing, we can hop on the phone after. So at the end of the call, we're going to go through a slide deck, and at the end, you'll get both my email, Gigi's email. Feel free to reach out to us. We're happy to hop on the phone and talk about pricing in more depth.
Yeah, and we'll also share the deck with all attendees afterwards, and it contains all that information. Does this support STP files if they are included in the CAD assembly?
Yeah, absolutely. So STEP was actually the first file type that we started with, being the classic industry standard. We take, 203, 214, 242, all the versions. We do recommend 214 and 242 just because they're a little newer. They've got more information, especially the color data. This itself is a STEP file that we're looking at right now. So yeah, that absolutely works.
And then with Operator Plus, this person would like to hear more about what data is collected and how it is accessed. Curious if we can capture component usage data and the productivity piece of OEE.
Yeah, no, that is a great question. So if we had more time, and maybe we'll do a dedicated Operator Plus webinar in the future. And so if we do that, we'll make sure to reach out. Also, feel free to reach out to us, and I can show you more about Operator Plus. I think we're running a little low on time today, but essentially, as all of these runs are captured, there's a dashboard that's available to the engineering team, and it shows you, what runs against what work instructions, who is doing them, the time, the date, whatever traceable information that you configure for your team. So whether it be serial number, lot number, work order, things like that. And then yes, it will actually show, we're capturing basically the consumption of parts and the usage of tools as well. So I think with that, Gigi, it may make sense for me to jump back over to the webinar slides.
Sure.
Are there any other
Do you have
burning
time for one more question?
Yeah.
Okay, one more and then we'll move on. If a step requires a separate operator check to confirm the step was completed correctly, is there a feature to record that for logs?
I'm going to wait to answer that question until we get to the product roadmap slide.
Awesome.
Yes, we're going to answer it there. So here, what I'll do, and actually that's the first thing we're going to start with. And so I'll jump into this. And I think this will answer a lot of the questions that, or at least a good amount of them that came up. So what we're breaking down here is, in my opinion and a lot of the opinion of the team, these are top priority features that we are actively working on today. And I don't want to promise too much, but should be available to all of our customers in, I'll say, the relatively near future. And to us, that means, a couple months. So just a little bit of background, because, we're kind of an emerging company. We're we're cloud-based, and you're accessing the application via the web. We are constantly pushing new features, and they just become available to you, right? Our customers receive an email. They'll see a little modal show up the first time they log in, since the new features, become available. And it says, hey, section views are available, or something along those lines. And then it'll walk you through a tutorial of that new feature. And the vast majority of these, just come at no cost. It's part of, the cool, cloud-based nature of the application that a lot of folks in the engineering world are not used to, right? Because most things are running locally on your machine. You purchased a license maybe 5 years ago and haven't seen an update since. So I just like to call that out as a pretty interesting aspect to, Dirac as a company and the products we offer. And then with that being said, I'll kind of dive into a few of these features that are coming up, that again are, right on, we're actively working on and we think are really important. Number one is fixtures. So fixtures is going to be the representation of the actual, fixture jig tool in 3D space. So what you'll be able to do as a user is you can upload a CAD file to a work instruction that represents a fixture. You can then place that fixture within the 3D CAD viewer in relation to the actual product you're building. And then you can indicate, hey, steps 2 through 6, I want to show this fixture within the work instruction. Now, this is super important because obviously fixtures, jigs, tooling is super common within, all the different, manufacturing environments that we're working in. And so we wanted to make that very easy to do for our customers. The other interesting thing too is that, like most things in the application, there's going to be an associative nature to this. So as you upload that fixture CAD data, we'll create a library of it within the application. That way you don't have to kind of go find that CAD file every time. And then we're also going to associate it to the parts that it's associated to. So, there's a particular housing that you always put this fixture, or always put onto a fixture, or there's something that you always need to press in using some sort of tool. That should just start showing up automatically within your work instructions, which is, really helpful. And again, a nice automation. I'm going to jump down to the bottom left here to section views, since I was actually able to demo that today. So section views, although a pretty straightforward feature, is really important for a lot of our customers, and I can imagine is important for some of the folks on the phone here. So giving that additional context of like, hey, where is this thing going within that housing, is really helpful. And being able to show that to an operator in an actual 3D environment on the shop floor is pretty powerful. The next one I'm going to jump to is smart model revision. So this speaks to, I know someone asked the question about, hey, what happens when I update my SolidWorks file? So right now, again, There is a little bit of rework associated with updating a CAD file or work instruction with a new CAD file. The future state, though, which we already have a pretty cool proof of concept of, is you have an existing CAD file. Let's say it's 50 parts. You make a work instruction for it, and you update 4 of the parts. The actual geometry changes. You upload that new CAD file to BuildOS. We will be able to recognize what parts are common, did not change, and what parts did change. And then we can automatically take your existing work instruction and apply that to the new CAD file. And essentially, you will never have to fully create a work instruction for that product ever again, right? Anytime you see an update to your CAD file, we will do the vast majority of the work to create that work instruction for that new CAD file in BuildOS. This can also and will also be applied across variations of your product. So another thing we see a lot is I have a product line and there may be 5 different versions of it, but they're very, very common in terms of the underlying CAD data or the actual design of it. And so starting to apply that across variations, right? So between variations within a product family, you're not recreating work instructions over and over again. So that's super, super powerful. And I'm really excited about that one. I'm then going to jump down to what we call Performant Assembly Planner. Uh, I was laughing with an engineer before the call because the engineer, named this feature, and he thought it was too engineering-like. But I said, our customers, engineers, this is appropriate. But essentially, what the Performant Assembly Planner is. So you saw how when I uploaded that CAD file, we were generating animations for you, and those were updating, as we go, which is great, right? That functionality is staying. But what's going to change is that we're going to do a lot more of that computation up front. And so it's going to feel almost instantaneous, right? So as soon as I change the sequence of my actual work instruction, that new path, right, or animation is going to automatically update, again, almost instantaneously. This is a huge engineering lift. We're actually kind of pioneering new approaches to a lot of this from like a physics and collision detection standpoint. So this is really, really cool new work that we're focusing on to make that experience even better and also allow you to make those work instructions even faster. And the final one I'll hit on here is PLMization. Again, kind of a funky name, but we're still working on it. So the idea here is to automatically break out and organize your work instructions based on the hierarchy of the CAD file. So what does that really mean? So that means that let's say you upload, top level product, let's just call it a car, for example, right? There's a lot of hierarchy associated with that. There are a lot of subassemblies in there. And so what we want to do here at Dirac is we want to tie, the organization of your work instructions to the hierarchy of your products. So when you upload that top level, we will automatically break out each and every one of those each and every one of those subassemblies into a work instruction automatically. So you actually can manage these separately. It's a little bit easier to kind of handle to make that work instruction. And then also, because subassemblies are typically common across many different products, whether it be different variations or entirely different products within your company, there would be a single source of truth work instruction for that subassembly that is then leveraged in all of those top level work instructions. So you're managing that in one place, and there can never be variations of that work instruction for that subassembly. This is really, really important from unifying and standardizing, and also leveraging the efficiencies we have based on identifying all of this CAD information. So standardizing that work instruction across every single top level in your entire organization. I'm sure I could dive into that a little bit more. It's a little philosophical, but that is the concept of a penalization feature. Okay, so we've got a few minutes left here. I'm going to jump to the next slide here. So this is our call to action, right? Thank you everyone for joining. Appreciate your time. We are happy to do demos with your actual CAD files. We can show that value to you, with your actual product. And along the left here is really just what we've seen with our customers of first and foremost saving time on work instructions. But on the production floor, we're also trying to reduce rework and scrap, increase the actual production efficiency. This is tied pretty closely to operator ramp up. Something we hear all the time is like, hey, we have new operators. It takes a while to train them and we don't have good documentation. We see ourselves as a solution to that problem. So getting those operators up to speed, building at the same rate that your most experienced guys are building at a lot faster. Knowledge retention, so also ensuring that these procedures, this know-how on the shop floor is captured in a really usable way, and that it doesn't take years to put together all the documentation. And then revision control is really important. So making sure that all this is traceable back to your CAD file and within your manufacturing organization. And so, we offer trial periods, we offer stage implementations. We're happy to get on the phone, happy to do demos. And so you've got both my email as well as Gigi's. Like Gigi mentioned, we're going to send out this deck after the fact so that you guys can have all of this. And please, please, please feel free to reach out. We're happy to get on the phone. Gigi, anything else you wanna say to close up here?
Yeah, just a couple of things. We had one more question come in, and in case anybody's only listening to audio and didn't see it, this attendee asked how large assemblies can be. Phil answered quite large. We've seen customers upload 15 to 30,000 part assemblies before, although being practical at that point, Phil mentions you're probably better off separating that out into separate work instructions. Trevor, do you have anything to add?
Yeah, no, that's great. I mean, from an actual like technical limitation standpoint, uh, we've been able to upload really, really large, files. But to Phil's point, we always do recommend, upload a file at the size that you want to make a work instruction for. So, um,
Awesome. Well, thank you everybody for joining. We will be sending the deck via email for any follow-up, and this recording will also be posted on our YouTube channel. So keep a lookout, and we'll catch you at the next webinar.